Hi everyone. In this lesson we're going to continue writing proofs involving angles. But this time we're also going to have parallel lines involved. So writing proofs involving angles and parallel lines. The instructions say, in each case, write an organized two-column proof with the statements and reasons. Add any labels needed for the proof. Let's take a look at number 1. And number 1 says, in the figure below, AV parallel to CD and BC parallel to DE. Prove that X is equal to Y. So notice here that we are not saying measure of angle X anymore, because if you notice in the diagram, X is a measure by itself. So we don't need to say measure of angle X anymore, because X is a measure, Y is a measure, so we will only say here X or Y. So to start the proof, we would identify the conclusion. This is the conclusion that we want to get at the end. We want to get that X is equal to Y. So this is the conclusion. This should be our last statement in the proof. So take a look at the givens. This is the information that is given to us, and this is what we have to prove. So we're given that AV is parallel to CD. Let me mark this on the diagram. AV parallel to CD. So these two segments are parallel to each other. And what can we get if these two segments are parallel? If you notice here, these two segments and this extra line BC or segment BC, they're forming a Z, which help us to identify alternate interior angles. So angle X, or I would say the angle whose measure is X, is alternate interior angle to this angle which doesn't have a name. So we need to add a name to it. So we're going to add the label here, and that is going to be, I'm going to put A degrees. So that is in the same format as the other one. So we can now say the angle whose measure is X is equal to the angle whose measure is A degrees, because we have these two segments parallel and X and A are alternate interior angles. So I'm writing that here in my plan. Now, because AV is parallel to CD, it's because of this that we can say that X is equal to A. So you need to mention this information here, which was given to you. You need to mention it because from here you are getting that X is equal to A. So this was given to us. And we know it because X and A are alternate interior angles. And we know that alternate interior angles are congruent. I'm just saying alternate interior angles here in the planning. Next, we continue with the other given, and the other given is that BC is parallel to DE. So let me mark that here on the diagram. BC parallel to DE. Remember that the arrows show on a diagram that they are parallel. So having these two segments parallel, we again see that with the segment DC, these two segments are parallel. So these two segments are forming alternating angles because they are parallel. So we can say now that whatever is alternate to angle Y should be equal to angle Y, which in this case is angle A. So I'm going to mark this here, this equal to this, and we know from the first one that angle X is equal to angle A. So actually all the angles involved in the diagram turn out to be equal, and that's why X is equal to Y. But now we're going to write here. So what we say here is that because BC is parallel to DE, then these alternating angles A and Y are equal. So BC parallel to DE, that was also given to us. And the conclusion would be that A is equal to Y, and that's again because we have alternating angles and we know that they are equal. And now we go back to the conclusion, and the conclusion that we want to get is that X is equal to Y. So how can we get X is equal to Y from the information that we have up to here? You have two equations here which need to be combined into one so that we could get X is equal to Y. So there are two things that we can use over here. We can use the transitive property because we have two quantities that are different, X and Y, but both of them are equal to the same quantity. Therefore, X and Y must be equal to each other. Or you could say, I'm going to use substitution because I can substitute this A by what's equal to A, which is the Y. So in the place of the A, I can just write the Y because we're substituting the A with the Y. So we could also do that. So any of those two properties will work fine over here. So X would be equal to Y because of the transitive property or because of substitution. So with this plan, you should go to write the proof, and the proof should look like this, going from the plan to the proof should look like that. Just remember that you have to put complete reasons as the statements here. And starting from now on, you could actually omit the planning. You could plan mentally, or you could plan on a separate piece of paper and just present the final product, which should be the organized proof. So you could do that from now on. If you really need it, you can still plan on a separate piece of paper. Now let's go to number 2. And number 2 says, given AB parallel to CD, prove Z is equal to X plus Y. So given that AB is parallel to CD, prove that Z is equal to X plus Y. Z is here, X is here, Y is here. How can these two angles X and Y, the sum of these two angles, be equal to angle Z? We're going to see it by now, or you should have any ideas by now. Just one important observation here. these angles are all marked in the same way. They are all using one arc, but in this case, they do not mean that they are congruent. I know that we mark in the same way to show that they are congruent, but in this case, actually in the whole worksheet, pages 1 and 2, the marks are not showing congruence. They are just being marked so that you can see which are the angles that are involved in the proof, but they are not congruent. So what can we do here? One of the things that we could do is draw an auxiliary line. I'm going to be drawing the auxiliary line that passes through the vertex of this angle whose measure is z, and that is going to be parallel to the segments AB and CD. So I'm drawing an auxiliary line passing through the vertex of angle Z. And okay, there it is. And what we have done with this one is we have broken this angle Z into two parts, which I'm going to call A and B. So this would be A and this would be B. Notice that they don't have to be congruent. They actually don't look congruent over here. They're just two angles that form Z. I'm also going to name this line that we just drew, and I'm going to name it EF. So we need this name so that we can refer to this line later on in the proof. And some observations that we could do here is, for example, we can see that angle Z is being formed by the sum of these two parts. Because Z has been broken down into A and B, we could say that angle Z right now is equal to the sum of A plus B, which is very similar to the equation that we want to get at the end. It's very similar to that one. So how are we going to get from this equation, which we know is true right now because it's on the diagram, how can we get from this equation to this equation? Well, since we have here parallel lines, and I'm going to put the mark over here to show that all the three lines are parallel, since these two lines or segments AB and EF are parallel, this angle whose measure is X is corresponding to this angle whose measure is A. They're forming the F that help us to identify corresponding angles. And what do we know about corresponding angles? We know that they are equal, so X is equal to A, so I can substitute over here the X in the place of the A. And if we look at the other part with lines EF and CD being also parallel, we can also say that these two angles are corresponding because they are forming the F that help us to identify corresponding angles. And so because corresponding angles are congruent, that makes the angle whose measure is Y equal to this angle whose measure is B. So Y is equal to B, and so I can come here and substitute the B with the Y, and I'm going to end up with this statement, which is supposed to be our final conclusion. So this is going to be our conclusion. And we already saw why and how we're going to get that. So basically what we have done, we have already planned mentally. So if that is enough for you, you can just go with that information and write the proof. Or if you really need to write the planning, you can do that, and I'm going to do it here. So what do we have? What do we say? So we could say here, because AB and EF are parallel, X is equal to A. So I need to say AB parallel to EF, but this was not given to us. This we're getting because we drew this auxiliary line. So I'm going to put over here auxiliary line. And now from these two being parallel, we know that A is equal to X because corresponding angles are congruent. And now we can also say, because EF is parallel to CD, B is equal to Y. So EF parallel to CD, again because we drew the auxiliary line, so that's going to be the reason here. So because of this, we know that B is equal to Y, because again, they are corresponding angles also, and they are congruent. Now what I'm going to do here is I'm going to put this equation here in step number 5, and then in step number 6 we're going to do the substitution and we're going to get our conclusion. So I'm going to write this: Z is equal to A plus B. And now we're going to write a reason which is new for us. We haven't been using this reason. And the reason for having this statement is the partition property. The partition property just says that if you have a big angle that is divided into parts, that big angle should be equal to the sum of the parts. And that's what we have over here. The big angle Z is divided into A and B. So the big angle Z should be equal to the sum of the parts. So Z is equal to A plus B. That is the partition property. The sum of the parts make up the entire angle. And now we're going to do the substitution. Instead of A, we write what's equal to A. And instead of B, we write what is equal to B, which is Y. And that is how we have Z is equal to X plus Y. And what did we do here? We simply substituted. So we're using substitution. And with this plan, you should go to write the proof. And the proof should look like this. In the same order, everything in the same order, with complete reasons here, either definitions or theorems or the names of the properties. And with this we finish page number 1. And I'm going to leave as the homework for you to do page number 2. So I'm going to show you page number 2. Page number 2 has 3 proofs. This one, it's very similar to number 2. And again, these labels are only to show which are the angles that are being involved: A, C, and I just marked here angle AEC. This is the angle AEC that it's referring to here. Those are the three angles that are being involved in the problem. They are not congruent, so please don't forget that the arcs or the marks here do not show congruence. And the next one, the same way. These angles are marked. They are not congruent. They are just showing which are the two angles that are being involved in the problem. And in the next one is the only one that is not involving parallel lines. Just these three lines, and they're all straight lines. So that is something that you need to keep in mind. They're straight lines, and you are going to complete these three proofs as your homework. Please make sure you put your name, the class, and the date here on the top of this page, written down with pen, and send it to my email. So that is for today's lesson.